Hey, this is Paul Solt from Super Easy Apps, and I want to continue the test-driven development tutorial series. So this was a talk that I gave for Lambda School, and it's on test-driven development, going through how to get started and working with time, how to write tests that can compare against time. So we've written our first test. Now we're going to write our next test, and that's to test the next piece of logic that we want to implement. So like if we go back to the design for this class, we've created the date installed. Our next step is to create the duration in days. Now, we're starting with an existing design of sort of where we want to go, but the actual functionality we're going to write as we write our test code. So our next test is going to be testing the duration in days property and verifying that that works as expected. So let's go ahead and write a new test. Now, I've got this on GitHub so that you can go ahead and follow along. I get the links down below. This is the starting point for this video, and we'll write our first test. I'll be tagging the different versions on this branch so that if you're following along in GitHub, you can go back to a certain point in time. All right, so let's get started. I'm going to create a new test. Now, I want to test the default duration is 7 days. Sort of the business logic going into this is the assumption that a trial period will, by default, be 7 days. So that's the goal of how this code needs to work. So let's go ahead and write that test code. All right, so what we're doing here is we're writing a very verbose test name. This way we don't need to have a comment or something that explains what we're doing. We explain what we're doing with the actual function name. And if we change it, how it works, we change the function name. And it's only one thing that we have to keep track of, and we don't have to worry about comments being out of date. All right, so that's a little aside about how I'm picking these names. Now let's go ahead and set this up. So I want to say expected is equal to 7 days. So we'll just say expected is equal to 7. We'll create our trial. And then our actual is equal to trial.duration in days. And I don't want a function, I just want a property. So that's how we'll do that. And then we'll just assert that these are equal. So let's say that our expected is equal to our actual. And we go ahead, we try to build this, and now we get an error. Okay, so we're missing the argument. So I forgot that we have to pass in the date generator. Okay, so there's some extra code that we're going to have to write here. So let's go ahead. In order to do that, we need a trial period. So let's create a, sorry, not a trial period, a time traveler. And in order to create the time traveler, we actually need a date. So let's go ahead and I'll create that as well. So that's going to be our starting point. And now let's use our date generator down here. We can pass in time traveler dot date and generate date. That's going to be our function. Now it inserts those parentheses. We need to get rid of those because we want to pass the function, not the function call. All right, so we try and compile. We get through sort of the red of the initial setup of getting our test down. It's not compiling because we don't have this property duration in days. Now, when I started this code, I am creating the class at the very top. So we just need to add this new attribute. So we want to test duration in days. So we're going to add our stub. So let's go up top, var duration in days. Notice I'm using a very verbose name so that it's clear what this is. This is going to be of type int. And now in order to get this to compile, we need to make sure that we say self.duration in days is equal to 7. Just trying to keep this simple. So we'll go ahead, insert that, and that will make it pass. But actually, I want the test to fail first. So let's make sure that this is set to 0. And we'll go ahead, run the test. And what we should see is red. So that's test failure. And now let's make it pass again. We'll do Command U to run our test, and it succeeds. So we've passed the test. Now we're in the refactor stage. Is there anything we can do to clean this up? Well, I don't like having magic numbers. So let's create a static variable that can store that default date. So let's create static let, and then we'll just call it something that is more obvious. So we'll call it default duration, and we'll just assign that to 7. All right, so now we want to make sure that we use that. So let's use trial period dot default duration, and we go ahead and we've removed the magic number from our logic. If you were using this in other methods, you can now all refer to this, and then it's just one place where we need to change this. We want to go to 21 days or something like that. All right, so that's one way to refactor. But I'm noticing something else, and you might have seen this. We've got some duplicate code. Now, it looks slightly different, but it's very similar. These 3 lines are very similar to these 3 lines. We just have one variable name that's different. And so what I want to do is refactor. So now we did the red, green refactor. There's a couple iterations to just get this code to compile, to get it to pass. We've got the simplest thing now working. We've refactored a little bit, but now we want to get rid of redundant code. So let's go ahead and do that. What I want to do is I want to pull this out, and with the unit tests, we can actually refer to all the same variables. And with each test, we can create new ones, which is what we're doing right now, but we can get it to do this whole setup process for us so that we can simplify the number of things in our tests. So you can see that we've got the act assert, we've got the arrange act assert flow, which is fine. But this is actually a pretty simple test, and we can condense this down to a single line test, and it will still make sense. For more complex tests, you'll still want this format, but if you can pull out redundant code, that's always a good thing. So let's go grab this. We're going to pull this out, and what we want to do is bring this up top. So we're going to have some variables up top. Now, I want them to be variables. So I'm going to select them holding the Alt key, and I'm just going to replace that with var to make them variables. And then I want these to be not created here, so I'm just going to clean this up a little bit. So I'm just going to set these up. And one of the things that we're going to see is that we need an initializer, and there's no initializers. So I'm going to actually make these implicitly unwrapped optionals. This is going to allow it so that we can use it the same as we've been doing in the code down below, but we don't need to initialize them right away. But this does require us to tell the system, okay, yes, I'm making a promise that I'm going to create this variable before I use it. Otherwise, it's going to be a runtime error. So we have a special setup method. It's a set with a capital U. And if we go ahead and autocomplete this, it will insert that code for us. So it's override func setup, which will allow us to do this. So we can call super.setup, which will be our starting point. So I'll do any logic in the super class that we're inheriting from, which in this case might be nothing, but we just put that in there for safety in case we do need that. And now we have to initialize each of these values. So we're going to say date is equal to date. Then we're going to create our time traveler is equal to time traveler. This needs a reference date, so we'll pass that date in. And then our trial is equal to a new time trial period. So we'll go ahead, create that. This takes a date generator. I'll press enter, and then we'll pass in time traveler dot generate date without those 2 parentheses. So I'll get rid of that. All right, so that will set up our logic. And if we run our test now, what we want to see is that the test still passes. Okay, so that's good. We've cleaned up some of the logic. Now, it's nice to have the separation, but again, this is a pretty simple test. So I'm just going to refactor it and move 7 down here and move this right here. And we can get rid of this code. So that was a bunch of refactoring. We'll again test, make sure that this actually does what it says. Now, what we have is clarity. This is a lot shorter than the amount of code that we wrote before, and it's very clear what we're testing. Okay, so that's our first refactoring. We can do the same thing with this one. And just to show the difference, I'm going to copy this and I'll just comment this one out so that we can compare. And let's refactor this one to use our new logic. So we're currently using a variable called expected, and we can rename that to just date. So down here, I can just call date and we can get rid of this stuff. So let's just comment that out. And we don't need our print statements anymore, so we can get rid of that. So cleaning this up, we get rid of all of that. And then we're testing against the actual date. So we can just copy this, paste it down here, and then get rid of this code. And then what we want to do is test that this actually works. Okay, so that's great. But this test doesn't really describe what we're doing. It just says test trial period, which is fine when we're getting started. Now what we want to do is describe what we're testing. We're testing trial period date installed is today or is now. And then we go ahead, we run that test. Now it's clear sort of what this is testing. And if you want, you can call that something else. So that's refactoring our test. I'll leave this one here so that you can sort of compare the difference. Typically, I don't leave code in, so I'll leave this for this branch, but I'll remove it in the next video so that we can clean this logic up. We don't like to have commented out code or commented out tests unless you're in the middle of refactoring something because something's not working, because this stuff goes out of date very quickly. There's no compile checks, and it's very easy to make changes that make all of this not work. So I'll leave that there for you to see. Now let's go ahead and try and run and write one more test. We want to test the expired date. So that's the next thing in our design. So if I pull up our design, we've got this date expired, and then we've got a is expired. So we've got two more things that I want to test, and then you can try and write the code for the reset trial yourself. So let's jump back over here and let's start writing our new test. So you can see I'm using a very verbose name. This is something that you just get into the habit of doing as you're working on this. And what I want to do is be very explicit of what the business logic I'm trying to test, and then actually go ahead and write the code. So because we've refactored a lot of the logic into our setup, we don't have to write all that redundant code to arrange and set up our date, our time traveler, or the trial. This is all set up. It's all good to go. It's going to be reset for every single test. So this gets called before this test runs, before this test runs, and before a new test runs. So we'll have a clean slate each time, which is really important for tests so that we don't have side effects from other tests making certain tests fail. Once you start to have certain tests that fail and others that don't, then you've got this test flakiness, and that's something we want to avoid by resetting our state to something that's known every single time and not letting anything get in the way of making sure that it works. So now we're going to work with time, and this is tricky because we want to create a time for a specific time into the future. And so there's a function on the calendar that allows us to get access to the current calendar on the user's device, whether that's the Mac or the iPhone, and we can change the date. So we can create a new date by adding date components, or we can add actual values. So in this case, I want to add days. I want to add 7 days from the install date. And so if we choose this method, date by adding value to date, this will allow us to do what we want. So the calendar component, we can see we can add days, hours, minutes, all of these fun things. So I want to add days. So I'm going to do .day, and I'm going to pass it 7. And the date that we're going to add this to is the date that is already initialized. So that's the one up top. So we've got a new date to work with. And then we just need to do our assert statement. So what do we want to assert? We want to assert this is equal to our date expired. Now you'll notice that this doesn't exist yet. So you're not going to get code completion. It doesn't have a member. We're going to scroll back up to the top. And one of the things that we're noticing is that we're doing a lot of scrolling. So now we're at a point where we've got a few tests going. It's time to start thinking about refactoring the logic after we get this code written. We've got our class in here, but we're going to extract this to its own code file after we get this passing. So the next thing we're doing is we're adding a date expired, and this is going to be a computed property based on our design. So we're going to create a variable, and this will be date expired. To make a computed property, we just do an open, close, open, close curly brackets. And then in here, we just need to compute the date. Now, I want to use the variables duration, and I want to use the date installed to create this date. I don't want to store a third variable that we have to worry about maintaining and making sure it's in sync. So in order for this to work, we're going to return a date. Now we can use the similar logic that we used down below. We can say calendar.current.date. And you don't want to run, when you're writing these, don't put the parentheses in because you'll lose the code completion. Just start writing by adding and then find the one we want, which is the 3 parameter one. And I'll just press enter. We'll add this for a day. We want to add 7, but in this case, we have a variable for that. So we're going to do our trial period dot default duration. This is getting a little bit long, so I'm going to put these on separate lines. And then our date is the final thing. The date here, we want to do date installed. And then I'll clean that up so it's on a separate line. So if we go ahead and do that, we're going to see that this returns actually an optional value. This should never be nil. There's a chance that it could be, and it's if you're calling it incorrectly or if the date doesn't exist. From all of my tests, I haven't been able to get this to fail, but there is the chance that if you're on a different calendar system or if you're adding some crazy numbers, there's an overflow or something like that, that the date might not be what you expect. There is another optional value here for handling overflows, so you'll see that in here as well. All right, so that will give us the date, and if we go ahead and run it, that will make this work, but that's going to cause this to succeed right away, I think. So I want to make sure that it fails, so I'll just add +1 or some other value. I could have put 0 here, and what we should see is that the test fails. We can click on that failing test here and see that the dates don't match. So it's comparing these two dates. So we see they're off by 1. And then to make this actually pass, we'll go back up and we'll get rid of this +1. We'll run the test and see what happens. All right, so that's it. We now have 3 of these tests running. I will stop the lesson right here and we'll pick back up in the next video. So what I want you to do, play with this code. We did a bunch of refactoring in the beginning. So I want you to think about how you can refactor your tests, how you can get redundant code out of your tests. If you imagine we have, what is this? It looks like 14 lines of code. There's a lot of comments. We don't need all that. It's good to have sort of for training wheels to get started, but in your actual production code, after you learn how to do test-driven development, you want to clean this type of stuff up so that it's easier to read, easier to see what's going on. And so when you can, you make it so that we've got even just 2 tests in the same amount of space that we had for a single test. And actually, I think we've got all 3 tests in the same amount of space. So when you do something like that, you make it a lot easier to clean this up. And I can remove this white space down here. This is just a 2-liner, so that will clear up some space so that it's very easy to read when it's short. It becomes more difficult when there's multiple things being created or multiple things being initialized. So that's where you'd want spacing to separate. And I would highly recommend that you don't put this expected in down here. It's just going to make the line too long and it's going to be harder to read. So by clarifying with a variable name that's appropriately named, you can make this easier to follow along. Since these were so short, it made sense to put them in right there. But in order to create an expected date, we actually have to write a lot of extra logic. So that's where we're going to end this lesson. I will create a tag on GitHub and I'll have links in the video to download this source code so that you can start at this starting point. All right, so thanks for watching, and I hope that this is helpful. Just make sure that you practice this. We've done refactoring and we've written a new test. See if you can write your own test before you watch the next videos. Think about something that you could test and then write it, and then see what I do in the next video and sort of compare notes. All right? Catch you in the next video.